Hello. So at this point, we've done a whole lot of inequalities. We're going to continue that. But it's helpful to just note that when we're talking about an inequality, we're talking about x or y or whatever variable it is having a range of values that satisfy. So if it's x is greater than 5, that means every number greater than 5 is part of our solution. So it's a range of solutions rather than just a one number thing. Okay, so now we're going to have more than one inequality. So here we might have something like, okay, we have x is greater than 1 and x is less than 6. So we're going to combine these two inequalities into one graphical solution. X is greater than 1 has an open circle going to the right. X is less than 6 has an open circle going to the left. Now, if we look at the leftmost region of the graph here, that doesn't actually work as part of our solution because it's not greater than 1. It might be 0. It's less than 6, yes, but it's not greater than 1. And on the right-hand side, we have numbers that are indeed greater than 1, so that's good, but it doesn't satisfy x is less than 6. Therefore, the only solution that is actually true is the one right in the middle because it satisfies both. So, and you need to have both true simultaneously in order to have this be part of the solution. So usually this is a conjoined line, not always, but usually. Let's take an example where we actually have the word or. Or means that either one can be true, okay? I don't have to have both true at the same time. So if I graph each of these, I have 1 and 6. So I'm going to start with x is less than 1. So I'm going to draw that with an open circle going to the left. And then x is greater than or equal to 6 is a closed dot going to the right. Now either one can be true, so I write that with both. That's my total solution, is just either one. Now, if I replace that word or with the word and, I'm going to check this region. Okay, so that region there works out for x is less than 1, but it's not greater than or equal to 6, so it doesn't work. The middle region, of course, doesn't satisfy either, and the right-hand region may satisfy x is greater than or equal to 6, but it does not satisfy x is less than 1. Therefore, there is no solution here. Moving on to another example. Let's say I have kind of a more complex example. I have sort of these two different things combined. Now, I'm just going to kind of manipulate this as if I have three sides to the equation, the middle and both sides. So I'm going to add 5 to both sides, then divide by 2, all the sides, and I'm going to end up with 2 is greater than r is greater than -2. Now, it kind of makes sense to draw this the other way around. So I'm going to flip it around. -2 is less than r is less than 2. And now I'm going to graph this. Okay, so if it's -2 is less than r is less than 2, then I see that r kind of ranges in this, between area between -2 and 2. And is implied. If I have like no words there, then I know that and is implied. So it would split up into r is less than 2 and r is greater than -2. And we can see that it would just be a conjoined line between those two numbers. Okay, and you can test either of the regions. I know that only the middle region is going to work to satisfy both of those requirements. Now let's look at an or. So we're going to have to solve both of these simultaneously. On the one on the left, I'm going to add 1 to both sides, then add 5 to both sides on the other guy. Then I'm going to get 2z's less than or equal to 6, or 3z is greater than 15. Okay, I keep solving just normal algebra, and I'll get z is less than or equal to 3, or z is greater than 5. Now, if I draw this, I'm going to take 3 and 5. Those are my 2 points of interest. Open dot for the 5, closed dot for the 3. It can be either or, so I keep both as part of my solution. Okay, continuing on. I have y is greater than or equal to -1 and y is greater than or equal to 3. This one's a little bit tricky. So if I graph y is greater than or equal to 1 in blue here, it's going to be a closed dot going to the right. But I'm also going to graph y is greater than or equal to 3 in green. Now I notice that there's actually only one place where both overlap, right? Both have to be true because this is an and. Okay, so both have to be true, so I only see both lines overlapping there with the blue and green lines. So therefore, y is greater than or equal to 3 sort of trumps, right? That's my final solution when I draw it, which is the region where they both overlap. So that's my final solution. Now, if I take a similar problem here, but it's actually or instead of and, okay, so I'm going to take that exact same solution, but now either one can be true, so it can be one or both, which means y is greater than or equal to -1 actually trumps, right? Because the blue is true, right? And it doesn't matter that green isn't true there, but we're just going to keep the entire blue solution. I'm going to give you another example here. Let's say I have y is less than 6 and y is less than 8, okay? So if I graph y is less than 8 in green, sorry, and y is less than 6 in yellow, then I see that there's only one region where actually both are true. And that means that y is less than 6 has to trump, right? Because it's the yellow line overlaps with the green line there. So that's the only solution that we end up with. Okay, so I see this new example, and we see that there are sort of two inequalities combined, which means this is really an and problem. So I'm going to split it up. Okay, so I just take the whole left-hand side, split it up, take the whole right-hand side and split it up. And then I begin to solve by combining like terms and dividing. Oh, I divided by a negative there. What did I do wrong? Oh, yep, I didn't flip the inequality, so let's go ahead and do that every time. And then on the other side, I continue to solve. This is just regular algebra, so I'm not showing it step by step. You can put this on slower if you want to go through the steps with me. Okay, but then we have m is greater than -3.5 and m is greater than or equal to 1. But if we look at this, they'll only actually overlap at m is greater than or equal to 1, so that's only our solution. So we just take the 1, m is greater than or equal to 1. We kind of ignore the -3/5 because both won't be true at that point. Let's take another example. This time we have an or. Okay, so we're going to start solving by subtracting m from both sides here. So I end up with -7/4 m because it's like subtracting 4/4 m. Okay, and then we're going to multiply by the negative reciprocal and make sure you flip the inequality there because we've multiplied by a negative. So I'm going to end up with m is less than or equal to 4/7. Same thing on the other part. We're going to subtract m and then multiply by the negative reciprocal. I end up with m is greater than -4/7. So I'm going to have -4/7 and then 4/7. I'm going to begin to graph this. So it's an or, so either one can be true. So if I graph m is less than or equal to 4/7, or let's start with m is greater than -4/7, it would be that yellow line there. And then if I graph the other guy, I'm going to graph it in green. It's going to be a closed dot going off to the left. But then I see that it's actually going to be all of the real numbers, right? They all work because the yellow line touches everything to the right. The green line touches everything to the left. It doesn't matter if they both overlap. So or is going to just include everything. Now I'm going to change up a few things here. I'm going to change the signs here. And then I'm going to change that word or to and. Okay, so then I'll get 4/7 on both sides. So if I graph each of these, then I see that they actually never both overlap. They're never both true, which means there's never going to be a solution that works. There is no solution. That will be all for today. Have a great day.